All right, 19 through 20, we're dealing with proportions in triangles. For number 19, for these to be parallel, they would have to split the sides proportionally. I mean, whatever that value is for AQ, I'd have to have 8 over x being the same ratio as 10 over 2. So when you cross multiply and solve here, you're going to get x would have to be 1.6. For number 20, this is an angle bisector theorem problem. What happens is an angle bisector is going to split a triangle proportionally. Now, if you want to look at the triangle how it is, you can kind of just set up a proportion here, where you go 12 over 15 equals x over 20. So you get 15x equals 240. And then when you solve for x, you get x equals 16. Now, you may look at the problem like this. A lot of times you'll see this problem where you have that bisector coming like down to a base where it would really kind of look like this. Okay, now the numbers are upside down, but really, again, my proportion could come right here. So I go 20 over x equals 15 over 12. But notice when I cross multiply, I'm going to have 15x equals 240 again, just like I did over here. So either way you set that problem up, you're going to get the same answer. Now for 21 and 22, these are a little different. These are altitude on hypotenuse problems. One way we taught these, we're setting these problems up with a geometric mean. You're going to get your geometric mean from starting at the top of the mountain here, whatever you want to call it. And then in the case, you're just going to slide down the segment that gives you a number. In this case, I'm going to slide down 8, and that's my geometric mean. If I slide over to 22, the path I would take is down at x, so that would be my geometric mean. So kind of jump in from problem to problem here. Similar setups, we start at the top of the mountain and pick a path. Whatever path we take is our geometric mean. Now it's going to be the geometric mean between two numbers. On 21, from this corner, I have a checkpoint here, and I have a checkpoint at the end. So the distances from my landing spot are going to be the two numbers that go in for the geometric mean. So in this case, this distance is 3, but the distance to my second checkpoint, I have to add those. So that's going to be 3 plus x. So what's going to happen here, I'm going to cross multiply and solve. So I'm going to do 3 times 3x, which is 9, plus 3x equals 8 times 8, which is 64. So when I subtract 9 from both sides, I get 3x equals 55. And then divide both sides by 3. So I get x equals 18.3. Now for the second version, when I slide down the middle here, what's going to happen is I can go to the checkpoint here from the middle, or from the middle I can go to the checkpoint there. So I don't need to add those together, so because I never go all the way across the bottom. I land somewhere in the middle there. I go left 4, right 6. Cross multiply, x squared equals 24. As a simplified radical, this becomes 2 root 6. As a decimal, it's going to be about 4.9. As far as 23 goes, we're talking about a scale model. So what I want to look at is I want to compare my height to my width. So on the model, it was 2 feet high and 15 feet wide. As far as the real building goes, I know its width is 5'10", and that's going to correspond to a denominator, so that's going there. What I don't know is the height, so that becomes my x. So when I cross multiply, I get 15x equals 1,020. And when I divide that by 15, I get 68 feet.